These utility trucks are waiting for the snow to clear before they can begin repairs. When extreme weather hits, our electrical grids face immense physical strain, and restoring power relies on a slow, manual emergency response. We see the same fragility in our oceans. This aerial view shows a cargo ship caught in a maritime bottleneck, one of hundreds of vessels holding up millions of dollars of essential goods. These crises share a common structural flaw. Our modern society relies on a centralized architecture, where massive cloud servers and corporate headquarters must process a staggering volume of global data before any local action can be taken. This creates a data vacuum. Right now, 90% of the information collected by internet-connected devices is discarded. Central hubs simply cannot handle the sheer influx of raw data required for real-time decision-making. When processing fails at the center, the entire system stalls. This creates a physical bottleneck that threatens the operational stability of the power, food, and water supplies we rely on for survival. Consider wind and solar power. Their energy output fluctuates in milliseconds. That speed outpaces the ability of a distant cloud server to receive data, calculate load balancing, and send a command back down the wire. A similar disconnect occurs in global supply chains. A headquarters halfway across the world remains blind to local ecological damage or labor abuses buried deep within its tiered supplier networks. Centralization, once viewed as a mark of efficiency, has become a rigid architecture that limits our ability to adapt to sudden changes. To stabilize our critical systems, we must move beyond building larger central brains. We need to equip the outer edges of these networks with their own independent capability to think and act. This shift is known as distributed intelligence. It pushes processing power away from the cloud and places it directly at the physical source where data is generated. This diagram illustrates the edge-fog-cloud model. Instead of a single central hub, data is intercepted and acted upon by outer nodes, like sensors and local gateways, before it ever needs to reach a server. A smart transformer on a residential street can apply edge computing, can measure local solar panel output and EV charging demands in real time. If demand spikes, the transformer autonomously reroutes power in milliseconds. It prevents local blackouts by making decisions on the street, without waiting for instructions from a distant utility center. This decentralization also provides a technical solution to our data privacy crisis through a process called federated learning. In this model, an AI is sent directly to your local device. The model learns from your data on site, then sends only its mathematical improvements back to the center. Your raw personal data never leaves your possession. Distributed intelligence solves the problem of grid latency and data privacy by transforming passive sensors into active, autonomous decision makers. This logic is evolving our software into multi-agent systems. Here, AI programs operate as peer-to-peer workers within a shared digital ecosystem rather than isolated tools. This flowchart defines decentralized artificial intelligence. Notice the branch for artificial life. It marks a transition toward networks that exhibit self-organizing and adaptive behaviors. Within these systems, autonomous agents negotiate for resources and computing power in real time. They optimize their own workflows and resolve conflicts without requiring a master controller. This requirement for local visibility and autonomy is transitioning from our digital networks into our legal and social structures. Inside the French National Assembly, lawmakers have passed mandatory human rights due diligence. This law legally requires corporate headquarters to monitor and respond to impacts at the furthest nodes of their global supply chains. This shift mirrors the Anima Gaia philosophy. True ecological resilience requires moving decision-making power away from distant boardrooms and returning it to local communities and indigenous stewards who live with the consequences. Whether we are optimizing silicon networks or human organizations, resilience depends on giving local nodes the autonomy to act and the ethical accountability to protect their environment. To ensure a decentralized network remains coordinated, we need orchestrated, distributed intelligence. This framework intertwines human ethics and strategic logic with distributed AI, creating a cohesive, adaptive system of action. This mirrors biological homeostasis. Look at how a mycelial network forms complex connections through the soil, managing resource distribution across disparate organisms to maintain the stability of the entire forest. Our future smart cities and power grids must function like this mycelium, acting independently at the local level while collaborating for the survival of the whole. To manage the years ahead, we must abandon the role of the centralized master controller. Our role is to act as the conscious stewards of this distributed intelligence, treating our technological and social infrastructures as vital, complex organs within a single integrated planet.